Yeah, very good morning, everyone. So the next chapter is matrices and determinants. So we're going to learn this chapter. So first we will understand what are matrices, how they are represented and all that. And then we will learn few of the functions of matrices, features of matrices, types of matrices. First we'll have to cover up all those things and then we will go to the problems. Fine. So let us start. So we will see what is given to us here. Suppose a company produces three types of products A, B, C, and each product requires three types of raw materials P, Q, R. Product A requires 3 units of P, 4 units of Q, and 3 units of R. Product B requires 1 unit of P, 3 unit of Q and 2 units of R. Product C requires 5 units of P, 6 units of Q and 3 units of R. So this is one of the situation that is given to us. So if you see here, there are three types of product, that is going to be A, B and C. So for each of the product, you require three types of raw material, P, Q and R. Again for B, you require P, Q, R. Again for C, you require P, Q and R. Okay. Now they have given us in detail how much units of P, how much units of Q and how many units of R is required to prepare the product A. Okay. When you have data given like this in big sentences, it might be confusing for us to understand which product requires how many units of P, Q and R. So we are going to represent this data by using a matrix format. Now, how do we do that matrix format is on one side, you will have the products being written, that is A, B and C. On the other side, that is as the columns, you will have raw materials. Okay, so these are the columns and these are the rows. A, B, C are the rows and P, Q, R are the columns. Now, read the question and just write the numbers in that particular place. Okay, I will rewrite the matrix here once again. So there are raw materials as columns, that is P, Q and R, and there are rows A, B and C. Okay, now let's read the first here. Product A requires 3 units of P. So product A, these are products. Product A requires 3 units of P, 4 units of Q and 3 units of R. Okay, if you see this, it is very easy for anybody to understand here that we need 3 units of P and 4 units of Q and 3 units of R. Then product B requires 1 unit of P. So product B requires 1 unit of P, 3 units of Q and 2 units of R. Okay, and finally product C requires 5 units of P, 6 units of Q and 3 units of R. Okay, so this such big data is being simplified here in the format. Now if you take out all this A, B, C and P, Q, R, and if you just put a square bracket or rectangle bracket like this form is called as a matrix. Some of them pronounces as matrix. Both are right. Okay, we will be pronouncing it as matrix. Okay, so it forms a systematic way of presenting unwieldy data. Okay, so the whole information that is there can be easily represented with numbers. And if you take out that ABC and PQR above, only numbers if you keep, that is nothing but the form of a matrix. Okay, so this is how we represent a matrix. It's just a systematic way of representing the huge data in a simple manner where you can understand it very, very easily. Okay, and these matrices and determinants are used in the production, especially in the production unit of a company. Okay, how do you mix the ingredients, what all should be added, so that the dough is done or the product is made. So that is what we are trying to find out here firstly. So did you all understand this part? Okay, now let us move on. Coming to the definition of a matrix. A matrix is a rectangular array. Array is nothing but arrangement of numbers in rows and columns. Okay, a matrix is a rectangular array or rectangular arrangement of numbers in rows and columns. So we will have rows. We will also have columns present in the matrix. The objects of a matrix are called as elements of a matrix. Object is nothing but each number that you see here. Okay, each of them is called as element of a matrix. 7 is an element, 9 is an element, 1, 5, 6, 8, all these are elements of a matrix. Okay, the horizontal lines from left to right are called as rows of a matrix. So if you see this matrix here, the horizontal lines are from left to right. So this is left to, this is right. Okay, so this is the first row of a matrix. Okay, and row is generally represented by M. Okay, so this is M1. First row is M1, next is M2, next is M3, next is M4. Okay, so we have M1, M2, M3, M4. In this example, we have 4 rows. Now, the vertical lines from top to down, top to bottom, whatever you see, right, those vertical lines, they are called as columns. Okay, so here columns are represented by N. So N1 is the first column, N2 is the second column, N3 is the third column. Okay, so if you consider this example, you have 1, 2, 3, 4 rows. You have 4 rows and then you have 3 columns. Okay, you have 4 rows and you have 3 columns. And matrix is denoted by M into N. When you think of how the matrix is being arranged, it is M into N. That is nothing but rows into columns. First will be rows always, and next you will have the columns. So this example, this matrix is nothing but 4 into 3 matrix. Okay, it is a 4 into 3 matrix. 4 rows and 3 columns are present in the matrix, and it's a 4 into 3 matrix. Understood? Understood the definition of matrix, rows, column? Okay, now we will move on for the next concept. General presentation of a matrix. Okay, so this is the next concept, general presentation of a matrix. A matrix is generally denoted by capital letter of English alphabet. So we don't use small letters here again. So we use capital letters, and matrix can be denoted in the capital letters of English alphabet. It can be any letter, you can use it. And its elements as small letters. Okay, so the elements of the matrix, that is whatever you see inside the matrix, these will be written in small letters, but the denotion or the matrix are generally denoted by capital letter. We'll read this again. A matrix is generally denoted by capital letter of English alphabet and its elements by small letter, enclosed by a ordinary bracket or a square bracket or a pair of double bars. So if at all you see a normal bracket like this for a matrix, then also it's a matrix. If you see with the rectangular brackets, then also it is a matrix. Or if you see just two lines on either side, then also it is a matrix. Okay. So that is the first way of seeing the matrix. So you can use a normal bracket, you can use a square bracket, or you can just use the lines. Okay, now if you see this matrix here, this matrix A has elements. So the first element is row A. Okay, first element is in the first row. And then if you see the numbers, it is the first row and first column. Let me erase this part here. Okay, so if you see this part, this alone, excuse me. So A is an element which is in the first row and first column. Now if you see the second one here, A is in the first row and second column. See, this is the second column, right? And it's in the first row. And this one is in the A13, is nothing but first row and third column. Okay. Then similarly, if you go on and do it, so it will be in the first row, but it can be in the nth column. So what is rows denoted by? Rows are denoted by M and columns are denoted by N. So always you will write it in the form of M into N. Rows into column. First row, first column. First row, second column. Okay. Now let's go to the next line. A21. So now this is the second row of the matrix. So second row, first column. Second row, first column. Then A22, second row, second column. Okay, like this. For the third row, it will be A third row, first column. A third row, second column. If it is 19th row also, A 19th row, first column. Okay, so this is how you will be denoting the general matrix, where first you will write the row and then the column number. Okay, so this will totally give you the value of Aij. Now what is this Aij? Let us understand. Two suffixes are attached to each element in the matrix. The first suffix indicates the row matrix and the second column number, and the second is the column number. The row number is denoted as I and the column number is denoted as J. So Aij means an element A in ith row and jth column. So which is nothing but Aij, means a number, the resultant number will be denoting or will be in the I row. I row, somewhere you'll have I row, and it will be in the jth column. Okay, now if you see here A23, for example, A23, you see 23 here. So A23 is nothing but it's an element which is in the second row and third column. Okay, so similarly A34, if you see 34, it is in the third row and fourth column. So it is easy for us to denote, or it is easy for us to search the number when we know these values of rows and columns. Okay, A23, 34, 14, and any number you can take. So this is the general matrix format that we have to understand. Clear? Everybody understood this part? Anybody has doubt? Okay. We shall continue then. 1 second. Okay. Next is dimension of a matrix. Dimension of matrix is how many rows and how many columns are there in a matrix is called dimension of a matrix. Now here if you see, a matrix with m rows and n columns has a dimension of m into n, read as m by n. So if you see let's take this example. If you see this capital A matrix where you have A, B, C and D, E, F. Now how many rows are there in this matrix? See, this is first row A, B, C, and this is the second row, correct? So how many rows are there in this matrix? Quickly answer. 2 rows? Okay. How many columns are there in the matrix? How many columns? 3 columns? Good. So this matrix is in the form of row into column, that is nothing but 2 rows into 3 columns. And how do we read it? We read it as 2 by 3 matrix. Okay, we read it as 2 by 3 matrix, 3 by 3 matrix, 2 by 2 matrix, 3 by 1 matrix, which means it has 3 rows and 1 column. So if you see here, it is 3, though it is only 1 element in each row, it has 3 rows and it has only 1 column. Okay, so to find the dimension, you have to first count the number of rows and then the number of columns to understand the dimension, and it is read by m by n. So this is the dimension of a matrix. A matrix has no value by itself. So if you just group a numbers there and put it into a bracket, it will not have any value. So once you are able to solve them and arrive at some value, that is when the matrix will get a value. So a matrix will not have a value by itself. Okay, understood the dimension of a matrix? Everybody understood? Okay, now let us start with types of matrix. Now in types of matrices, first one is called as a row matrix. Now in row matrix, you will only have one row of a matrix. Okay, it will only have one row of a matrix, and the dimension of the matrix will be one row. First is row, right? R into C, rows into column, which is M into N. So there will be only one row all the time, but the number of columns can be any number. Okay, the number of columns can be more, but the row is going to be only one. So if you see the example here, the matrix A has only one row. So what are the elements of matrix? 1, 2, 3, 4 is given. You can add anything more, 5, 6, 10, anything you can add upon that. So let's say this is a row matrix. Now in this row matrix, I have only one row, but how many columns do I have? Who can say me? How many columns do I have in this row matrix? Seven columns. So 1 into 7 will be the dimension of the matrix. Now if you take this example, A, B, C, D, E, F, there is only one row, but there are 6 columns which is available. So that is why it is 1 by 6 matrix. Okay, so that is called as row matrix. Now, opposite to this, column matrix. Now here you will have only one column. There you had only one row. Here you will have only one column, but you will have more rows. Okay, you will have more rows here, which is nothing but, if you see this example, A is equal to, you have only one column. But see the rows, 1, 2, 3. So it is a 3 by 1 matrix. That is the dimension of the matrix. 3 by 1 is the dimension of a matrix. Okay. Now, say me what will be the dimension for this. Let's say A is equal to X, Y, Z, A, B, C. Who can say me what is the dimension of this matrix? I want full dimension. Rows as well as columns. Very good. 6 rows and 1 column. So that will be 6 by 1 matrix. Okay. And it is a column matrix. When you have only one column, it is called as a column matrix. Okay. So clear with the first two types? Any doubts in the row and column matrix? Okay. Now, moving on to the next type of matrix is square matrix. Now, in square matrix, the numbers will be, the number of rows will be equal to the number of columns. Okay. So, if you see this example here, you have 2 rows and you have 2 columns. You have 3 rows, you have 3 columns. Okay. So here the number of rows will be equal to number of columns, and therefore you will have 2 into 2 matrix, 3 by 3 matrix, 5 by 5 matrix. Both the number of rows and columns will be same. Okay. So we are not bothered about what are the elements inside. We are bothered about how many elements are there in the matrix. That is what is the primary concern. Okay, so that is your square matrix. Now, moving on further, let us see the next type of matrix, that is diagonal matrix. Now, in diagonal matrix, it is a square matrix. Now, what is a square matrix? Square matrix is something where the rows are equal to column. Similarly, in a diagonal matrix is also a row matrix. Okay, so a diagonal matrix is a row matrix. If you see the example here, you have 3 rows and 3 columns. Or you can also have a diagonal matrix with 2 rows and 2 columns, something like this. Let's say 4, 0, 0 and 6. This is also a diagonal matrix. Okay, here you have 2 rows and 2 columns. Fine. A square matrix having a non-zero elements in the principal diagonal. Okay, these definitions are important because they can ask for 2 marks, and you can expect one question might be in 6 marks or 14 marks asking to explain all the types of matrices. Okay, so carefully understand. A diagonal matrix has a non-zero element except 0. Some number plus or minus does not matter. Okay, non-zero elements in the principal diagonal. Principal diagonal is this. Okay, from left to right, this is called as principal diagonal. Fine. So this principal diagonal should have non-zero elements and rest of the elements should be 0. Okay, even if you see this here, principal diagonal has elements and the other 2 are 0. So this is known as a diagonal matrix. Once again, I'm repeating it once again. Diagonal matrix is a square matrix wherein the number of rows will be equal to number of columns. So if you see this, it is a 3 by 3 matrix and this is a 2 by 2 matrix. Correct? Number of rows is equal to number of columns. So principal diagonal elements should be non-zero and other numbers should be 0 in a matrix. In other words, a square matrix in which all elements except those in principal diagonal are 0 are called as diagonal matrix. Just another definition given. You can follow whichever is convenient for you. You can write this or you can write this. Any sort of definition you can follow. So that is a diagonal matrix. So did you all understand diagonal matrix first of all? We'll be using all sorts of matrices when we come to problems, when we start solving problems. Okay. Now, moving further to the identity matrix or unit matrix. Now, when it comes to identity matrix, it is again a square matrix. So, square matrix, what is square matrix? Where the number of rows is equal to number of columns. A square matrix in which every principal diagonal, what did I say? That one which is from left to right. Okay, left top to right bottom, that is called as principal diagonal. So a square matrix in which every principal diagonal element is 1 and other elements are 0. So the basic thing that you'll have to understand here is this is the principal diagonal which is 1. It should be 1 only. You cannot have any other number there. If you have any other number, it will become diagonal matrix. Okay, if you have 1 only for all of the elements in the principal diagonal, then it is called as identity matrix or unit matrix. Okay, and this is specifically denoted by capital I. Okay, identity matrix are specifically denoted by capital I. So if you see, this is a 3 into 3 by 3, 3 into 3 or 3 by 3 matrix where you have the principal diagonal to be 1. Now let us consider this other example. Here it is a 2 by 2 matrix and here also the principal diagonal values elements are 1. So this also can be called as identity matrix or unit matrix. Except the principal diagonal, every other element, if it is 0, and the principal diagonal is 1, then it is known as identity matrix. Understood? Okay, so no confusion between diagonal and identity matrix. In diagonal matrix, you can have other numbers. Yes, it will be from left to right only. That is the principal diagonal. Okay, it should be from here to here. It should be like this only. That is only called as principal diagonal. Okay, now identity matrix has one more definition. You can just go through it. Next, going to the next type is a scalar matrix. Now in scalar matrix, it is a diagonal matrix. So scalar matrix is a diagonal matrix. What is a diagonal matrix? Diagonal matrix is a square matrix where the elements of the principal diagonal is a non-zero element and rest of them are 0. Correct? You should study then and there. Positions won't change. No, Anas, positions won't change. You will understand when we solve the problems. Okay, principal diagonal is from left top to the right bottom. Okay. So we are studying scalar matrix. Scalar matrix is a diagonal matrix. What is a diagonal matrix? Diagonal matrix is a square matrix which is having non-zero elements in a principal diagonal. So, which means that in scalar matrix also the number of rows should be equal to columns. So, M should be equal to N. That is a scalar matrix. Now, we will look into the elements. Scalar matrix is a diagonal matrix in which all the elements in the principal diagonal are equal. Like how you saw here in the unit matrix, everything will be 1, right? So here it can be any number. Any number it can be, plus, minus, no problem. But the diagonal, the principal diagonal elements will be the same number. Don't get confused between diagonal matrix, unit matrix, scalar matrix. Okay, so the diagonal, the principal diagonal elements will be same number, or it's called as equal. The numbers are going to be equal. Understood? Okay, now going to the next type of matrix, that is zero matrix or null matrix. Now in zero matrix or null matrix, let us read what is there. A matrix of any order in which all the elements are zeros. Very easy. You take a matrix where all the elements are 0. That is a null matrix. Okay, or it's directly called as a zero matrix, and it is denoted by O, capital O. Okay, so capital O is nothing but a zero matrix here. So even if it is one element, it is a zero matrix. Even if it is a 2 by 3, 2 rows and 3 columns, so 2 by 3, and here it can be of any form. 2 by 3, 3 by 3, 4 by 4, 4 by 3, 4 by 2, any form of matrix or any dimension of matrix it can be. Any dimension of matrix it can be, but all the elements of the matrix, excuse me, all the elements of the matrix is going to be 0. Next, upper triangular matrix and lower triangular matrix. We will understand this together. Now, if you see, let me take this color. Now, if you see this matrix here, for example, okay, now the matrix, let's say, has 1, 2, it's not 0. Okay, I'm just putting a small dot there. If I put a dot, you will not be able to see. So that's why I'm putting it a little bigger. Okay. So if the matrix, let's say, has, it's a 3 into 3 matrix. It's a square. It is supposed to be a square matrix. Okay. So this is the principal diagonal. This side of the matrix is the upper triangle. Okay. This side of the matrix, see, if you see and join all these numbers here, it will form a triangle. So this is called as upper triangle. Okay. Now similarly, if I draw a triangle to the other side, this is onto the lower part of the matrix. So this is called as lower triangle matrix. Okay, so the first half is called upper triangle matrix. The second half is called lower triangle matrix. In upper triangle matrix, see, this part of the matrix will have the numbers. The other part will be 0. Even if you see in this big matrix, this is a 4 into 4 matrix, 4 by 4. Even in this, the upper triangle, all elements are present. The lower triangle, you see, everything is 0. Okay, so this is a upper triangle matrix. When it comes to lower triangle matrix, the lower part of the matrix will have numbers.